Welcome everyone, a very warm good afternoon. My name is Luca Tommasi. I am the European Marketing Manager for Agilent's Calibration and Repair Services in EMEA, and I am your host for today's webcast entitled Demystifying Calibration Accreditation, which will be presented by Bob Stern and Trevor Thompson. This webcast is the third and actually last of a first cycle of Calibration Web Seminar Series. And let me just point out a couple of operational notes before we begin. Just like the previous couple of meetings, this is a lecture-style meeting only, so your microphones will be muted by default, so just sit back and relax and enjoy the presentation. However, we do encourage the audience to ask any questions or clarifications you may have by using the question and answer chat box in the panel of the screen, which you can find on the bottom right corner of it. We will answer, or at least attempt to answer, all the questions at the end of the presentation. The questions will be asked in an anonymous form, so your name will not be revealed to the rest of the people participating. So in other words, just feel free to ask any questions at any time, and we'll make sure that we'll take them either at the end or we'll reply over the email. The webcast will be recorded, so you will be receiving a thank you email notification after this meeting is over with a link to the recording. And the final comment is that as soon as we conclude the web seminar, we will ask a couple of minutes of your time to briefly fill an evaluation form that will greatly help us in making even a better job next time around. So let's move to the panelists today, and the main presenter is Bob Stern, Senior Metrologist in Agilent Technologies. We also have Frank Weider, who is our European Service and Support Quality Manager and 17025 Auditor. But we also have a very, very special guest speaker today, Trevor Thompson, who is the Accreditation Manager with UCAS, the United Kingdom Accreditation Service in London. Prior to working at UCAS, Trevor has extensive experience with his predecessors, NAMAS and the British Calibration Service. He's responsible for electrical and physics accreditation, mainly 17025 testing and calibration, but also 17020 inspection bodies and Guide 65 product certification. He represents UCAS at the European Accreditation Laboratory Committees. I really, really appreciate Trevor's presence, so let me just hand it over to Trevor for a few introductory words, and then we can get started. Trevor?
Okay, thank you. Well, it's a pleasure to be here this afternoon, and I very much welcome Agilent's initiative in providing this presentation. It is indeed a pleasure to be with you, and I want to acknowledge the role that Agilent has played in accredited work in the United Kingdom. As one of the major manufacturers of top quality equipment, Agilent has provided us with the opportunity to accredit them for a very wide range of parameters and a variety of levels of service, and more about that in the presentation. So we have some of the lowest uncertainties and some of the more production type service facilities available in accredited form, as well as some levels of service which are not accredited, but with the same parameters and many of the same features, hopefully. More about that later. So, Agilent, in the form of Hewlett-Packard, has been accredited since 1984. So, Agilent has much experience of the use of accreditation in the UK, and I'd like to think that they make good advantage of this. So I'll be talking to you a bit later about several aspects of accreditation and the certification associated with it. And I'll now hand you over to Bob Stern, who will start the presentation. Thank you.
Thanks very much, Trevor. So there are a number of questions that we oftentimes hear from our joint customers on accreditation, and so we're going to look at various aspects of that today, both Trevor and myself. But before we do that, I wanted to just do a little bit of review and perhaps have a little bit of fun. So having lived in Europe myself, I know that you have different names for your freeways, but since Trevor is on the line, we're going to call them motorways just for the beginning. So for anyone who's ever been in Britain and driving along, I'm just going to ask, how fast do cars travel on average? And here's a hint. The answer is not whatever is the posted speed limit. Well, this was supposed to be. You were supposed to hear a siren. In any case, let me just mention that if you were on the autostrada and you were going a little bit too fast, you might get a visit from the Carabinieri here. And so I mention this only because we all know that the law or the rules, there is a speed limit, and when we're in a hurry, many of us are thinking, okay, what do I really have to do, and who's going to tell me what I really have to do? It's sort of that simple. So I draw a parallel to calibration because if you're a person who has turned your instrument in for calibration and you're trusting that your calibration provider is going to test those thoroughly against ISO, IEC 17025 or other standards, then how do you know that that's being done? Well, it isn't just what that laboratory is claiming. Oftentimes, if they're accredited, then really, and so here you have, Trevor probably wishes he had a car this fancy, but it's really, and I know that sometimes the accreditation bodies are sensitive to the word enforced, but really as they're doing that assessing function of a calibration laboratory, calibration is really about trust. And you can have more trust in a laboratory if you know that a qualified third party who really understands those calibration standards, like UCAS, has done a thorough assessment of them and has posted that on their website. So that just gives kind of a little bit of background. I wanted to position where today is in the middle of a series of calibration YouTube videos that Agilent has been doing. So just to give you an idea, we did a webcast on the 13th of November on 3 of the topics that you see circled in blue. And last December, we also talked about traceability and standards compliance. And those 2 webcasts were really, if you haven't seen them already, if we say something today that we go a little bit fast on measurement uncertainty or traceability or something like that, I would encourage you to go back and look at those. They're available either as YouTubes or as on-demand videos of the previous webcasts. So today, as Luca mentioned, is the 3rd in our series on accreditation. Most of you in Europe don't care so much about American national standards like Z540-1, but for those who do, there is in fact one more of these webcasts that's coming. So just quickly, the calibration videos, you see a link at the top there. That's where you can go to see all of the YouTube videos that we posted so far. And as of yesterday, I believe they put one on, they posted one which is about 10.5 minutes. So if you have a boss or a colleague that wants to get a really short view of accreditation, personally I think it's almost impossible to do in 10 minutes, but we did our best. So there's a nice YouTube video there. And with that, I want to make just a very short review of a few key concepts before we dive into accreditation. So first, and this goes back to our very first webcast and the first video. For those of you that are, if either you or you know someone else who is responsible for measurements in your organization, and when you're sending an instrument in for calibration, I ask you to just think briefly, what is it you really expect them to do? I know sometimes when I'm live and in person, people go, well, they brought you here, aren't you going to tell me? And a lot of times people make assumptions, and those assumptions may be true, they may not be. So I encourage you to think about that. I'm going to just respond by saying that with respect to calibration, if you want to see a formal definition, and for anyone who's a metrologist on this phone call, I have the official link to the international vocabulary down there. Not everyone knows my sense of humor, so I'll take a chance here. But I recommend that you go read that if you have trouble sleeping. It's very technical, it's correct, but it's a little hard to understand. And for many of you who don't spend all your time being a metrologist, what we're really trying to do in this series is make things simple so that you can understand them in generally in terms that you're used to. So in terms of calibration, really it's all about characterizing your device or an instrument if that's what the device happens to be. And when we do that, what we say is, what are you doing? Well, you're making actual measurements of the actual performance. Well, as soon as you have a measurement, then the first question that comes to mind is, great, how accurate was that measurement? And of course, as we mentioned previously, in the metrology world, we don't say accuracy. We refer to that as measurement uncertainty, generally expressed as a standard deviation when you take all errors into account. Okay, now you have a measurement. You know how good that measurement is with your measurement uncertainty. And the next question is, if that happens to be an instrument and it happens to have a specification, then the question is, did it pass or did it fail? And in the metrology world, we call that a statement of conformance. And I think Trevor is going to point out the standards say that you should take that measurement uncertainty into account when you make a statement of did it pass or did it fail. Now then, if you actually observe that, oh, gee, we're sorry, but your instrument failed the specification, it was out of specification, in that case, 17025 says, well, then you're supposed to advise the client if you find it out of tolerance. And at Agilent Technologies, what we do is that we will normally, unless we're instructed otherwise, we go ahead and adjust the instrument, repeat the calibration, and then provide a second set of data. So that's kind of a review of, what is the calibration process. And you can see over on the right-hand side in yellow, today, accreditation is really the confirmation of the competence of the laboratory. Do they know what they're doing? Do they have the skills? Do they have a quality system? Are they operating according to ISO 17025? And of course, when you do an assessment, it's only as good as the competence of the assessor. And that's why the third parties that do this are highly trained people coming from accreditation bodies, for example, the United Kingdom Accreditation Service. And I think this is my last of the reviews. Yes, it's the last of the review slides. One last comment to all of you engineers out there. I know, because I travel a lot and I've met very many people from a number of customers, that you spend a tremendous amount of energy before you purchase an instrument to make sure that that instrument has the proper specifications for your company. And then you put together a test system or whatever, could even be automated test system, where you're measuring items that you have of your own which need to be meet a certain specification. So when you receive a calibration back from Agilent, we provide every measurement that we have, we will provide you with the actual data of what we had. So what I like to say is that the measurement report is the physical evidence of whatever work was performed. We believe that you should always get a measurement, and if any of you have ever traveled in the States, you know that our license plates are quite a bit different than the ones that you have in Europe. But I brought this one from the state of Missouri. They have a state motto. Apparently some famous person some time ago, they were asked, someone was trying to make a statement to them, and their reply was, well, I'm from Missouri. You'll need to show me. So I just put this in for a little bit of fun. When it comes to calibrations, I think everybody should be from Missouri. In other words, the cal provider should show you all the measurements that they made so that you can do a review of those. And in particular, the best, most important ones to review are those specifications, or how did the instrument perform at the calibration event for those specifications that your company really relies on. So much for the review. Now what we're going to do is I'm going to hand it over to Trevor, and we're going to go into the first of our two main topics today. Trevor?
Thank you, Bob. You'd expect me to say, as accreditation manager in UCAS, that you should always ask for an accredited calibration, and it would be great if you did. However, I would ask that you think about the significance of a laboratory holding accreditation, whether or not you're going to use an accredited service. More about that in a moment. An accredited lab has proved that they are capable, at least, of getting a good answer in a measurement with a known uncertainty. Why does this matter? It matters because accreditation bodies send qualified and experienced technical assessors to accredited laboratories to assess all the things shown on this slide. And I draw out particularly the technical competence of staff. You don't get accredited unless you can show that your staff understand how to make measurements and get the right answer in a measurement, with the uncertainties being taken into account. The test methods must be appropriate and valid, and these things are assessed. Now, when you choose a non-accredited service, you may or may not be getting this, and more about that later. But the point is that the company is capable of doing it. And on the next slide, you can ask for compliance with a variety of standards. If you ask for a compliance with 17025, and you ask for it to be accredited, you will get compliance with 17025, and the accreditation body will ensure that the laboratory also complies with various, what you might call lower documents that contain more detail about good practice in making a decent measurement. The first one below 17025 on this slide, Guide 98, is more commonly known as the GUM, and it is a very, I would say, heavy document about how to calculate uncertainties of measurement. Accredited laboratories must be capable of doing that. The ILAC documents mentioned here, and ILAC is an international cooperation of accreditation bodies, and they've got some guidance and some requirements documents, and there's one about the assessment and the reporting of compliance with specification. Very important if you're going to issue a pass-fail statement. And the ILAC policy on uncertainties. So those, combined with having a management system, the requirements of which in 17025 are broadly the same as in ISO 9000, you can be sure that the laboratory you've chosen is capable of getting the right results. On the next slide, each accreditation body is a signatory to an international regime of some sort. Most of the ones in Europe belong to EA, and EA has an arrangement within the ILAC multi-recognition arrangement to ensure that the results of the accreditations within Europe are comparable with those in the United States and in other regions. And this is done through the accreditation bodies having to comply with the standard 17011 and to follow some ILAC documents, some of which add requirements, and there's some argument about whether they add them or whether they just interpret them, but nevertheless, an ILAC arrangement accreditation body like UCAS and like all, I think, or most of the American ones, do follow the requirements on reporting pass-fail criteria, although it is interpreted slightly differently in different countries. You can't use the logo of ILAC or the logo of an accreditation body unless you're issuing an accredited certificate. And you'll see to the right of this slide that we have the marks of a variety of accreditation bodies and the use of the ILAC arrangement mark as well next to it. If you go to one of those laboratories, if we just go back for a second, if you go to one of those laboratories and you don't ask for an accredited certificate, you are on your own as far as the accreditation body underwriting the credibility of the procedures and of the budgets, etc. But most of the reputable laboratories, and indeed most of the manufacturers and the larger people, will use the same management system throughout their operation. But I would always suggest that you ask for an accredited 17025 calibration, but you are free to ask for a variant, which might be less in some ways and wouldn't bear the accreditation mark. But if you go to an accredited laboratory, you can be sure that the competence is there in the organization. Now, on the next slide, looking at the certificate of accreditation is only part of the story. So when you go to an accredited lab and you see it's an accredited lab, that's one thing. But you want to see what they're accredited for. This is absolutely vital because some people are accredited for a small amount of parameters. This could be the main functions of a multifunction instrument, say voltage and current, but might not include some of the more complex and relatively obscure measurements which you may well need. So you need to consult the schedule of accreditation, as it's called in the United Kingdom. It's called the annex to the certificate in the case of many of the European accreditation bodies. But don't just ask for the certificate, ask what they're accredited for. Again, whether or not you're going to use accredited services. When we assess laboratories, we assess that they have documented procedures and staff competency for each individual measurement that they're accredited for, as well as having the traceability of measurement, which is required to be accredited. And again, if you're using non-accredited services, most companies who are accredited would have the same traceability arrangements with varying uncertainties, even for non-accredited work. In the United States, the traceability is usually to NIST. In England, in the United Kingdom rather, it's mainly to the National Physical Laboratory, and each European country has an NMI, PTB in Germany being another notable European one. They all take part in a multilateral agreement arrangement as well. So there's lots of people assessing your instruments when you get involved with accreditation and the National Measurement Institutes. The certificate of accreditation shows the standard to which people have been accredited. In Europe, it's almost invariably 17025, although there are some medical laboratories for 15189. In the US, you will also get the Z540 series accreditations. But as I mentioned earlier, that certificate's fine, but you need the scope as well. Now, when you look at the scope, what you should see is the parameter being mentioned and the range of measurement and any detail needed to augment that, and the uncertainty of measurement. Now, with some parameters, that's very simple. These schedules can be enormous. The one that we're looking at here, which is indeed Agilent's one, I think, has 53 pages. That's Agilent's American one from A-class. There's a lot of measurements there, a lot of parameters. Do you need these for your kit? You may need many of them. You won't get all the ones you need if you go to ordinary unaccredited laboratories. And on the next slide. So if you, this is making the same point really, if you compare the accreditation certificates of two laboratories, those two look the same. But if you tabulate on the next slide, you tabulate what's on their schedule of accreditation, or the annex to the certificate for the European people, you will find that a modest laboratory may only have the main parameters. In this example here, we have DC voltage, current, resistance, and AC current only, but not voltage. That's unusual. Anyway, there's a lesser laboratory. He's got the same certificate. He hasn't got the schedule that a large, comprehensive laboratory like Agilent has got. So, what are the risks associated with going to one of the other laboratories? And I'll hand you back to Bob to discuss that topic.
Trevor, when I invited you to join us, I knew that you would be a good speaker, but I didn't realize, just listening to you now, I realized I'm going to have to go back and listen to the recording. It's that you've done that well. So thank you. That was really, really clear as I've ever heard. I wanted to talk a little bit about what, just drawing a diagram on that last page that Trevor was showing you, where there may be unaccredited parameters. So you were looking at two prospective labs, and it really doesn't matter who they are, but let's say that Laboratory A and Laboratory B make an actual measurement and they get the same result, and it happens to be that it's inside the specification. So as a user, you could receive this instrument back, and it could say you passed, you're good to go for another year. Well, again, is this all the information that you need to know? As we mentioned earlier on, and as Trevor was, the ISO GUM, or the so-called GUM, the Guide for Expression of Uncertainty of Measurement, I'm showing two yellow intervals here, and these would represent the statistical interval over which you'd have a 95% expanded uncertainty interval. And so what that really means is that when we look at these two measurements, it's two different laboratories, but I'm going to show you that the areas that are shown in red, the true answer, we don't really know where the true answer is. It could be anywhere in that yellow interval. If the true answer happens to be in the portions that are shaded in red, then in fact that instrument was observed in specification, but it's really operating out of specification. And so this shows you just how important the measurement uncertainty is. And in fact, I like to make the claim that the actual instrument accuracy that you as a user can depend on is really only as good as the expanded measurement uncertainty of the last calibration. So it has to be measured, and it depends on the actual measurement uncertainty. Now, if you're looking at this chart and you've not seen this from me or anyone else before, you might be saying, my gosh, is that really realistic that something over on the right-hand side there, the case B as it were here, could be, the uncertainty could be as large as that? And what I'm telling you is that in my practical experience, oftentimes when I'm asked as a technical consultant to look at the differences between calibration measurements between two different laboratories, I find that if a laboratory is, sometimes they don't actually even include a measurement in the report, so I don't know if they made the measurement or not. But when I look at the trace information, I can at least see which instrument they used. And having been a long-term employee of HP, I know those instrument block diagrams well enough. Anyway, what I am able to tell you with some confidence is that I'm afraid that quite often when there is a parameter which is not accredited, oftentimes the actual measurement uncertainty, although we don't know what it is, would be at least as bad as what we're showing you in the case B. So I think what you can say here really is that for parameters that are outside the calibration measurement capability or the schedule that Trevor was mentioning just a moment ago, you really have no idea what the size of that risk bar is. The only thing you can say for sure is that it was not assessed. Now, I know human nature well enough to know that when any lab has really good measurement uncertainty, for example, as what's shown over in the case A here, then no self-respecting metrologist would slow down. They would tell the assessor, by all means, accredit us for that parameter. On the other hand, if you have older instrumentation, and oftentimes even something as new as 10 years ago, the block diagrams of all of our spectrum analyzers, for example, have completely digital IFs now, and the accuracy that they have is incredible compared to even just a few years ago. So if you're calibrating a signal generator, for instance, and you're using one of our spectrum analyzers as a receiver, you need the very latest ones, because those are the ones with the block diagrams that are going to give you the kind of measurement uncertainty that you see on the left. And other ones would be quite a bit more. So it's definitely something to think about. So in terms of, so where do you find out where these schedules of accreditation are? At Agilent, we try to make it real easy for you. So there's really two ways you can find out. One is we have a little jump station link, agilent.com/find/accreditation. assist, or hash, I think you say. That will take you to a table, and the table looks a lot like this. So worldwide, at my company, Agilent, we operate all over the world, and we use 15 accreditation bodies around the world. And you can always go to, if you happen to know, for example, Agilent is accredited with UCAS in the United Kingdom, and certainly Germany and Italy, et cetera, in Europe. And so you can go to the UCAS website and look at their list of accredited laboratories and find our schedules of accreditation there as well. So finally, I'd like to just offer a little checklist of points that Trevor and I are wanting to make on this first portion of the of accreditation. So we're going to be talking about specific requirements for when you ask for the accreditation symbol on the certificate in a moment, and Trevor's going to take that over. But just to close out this portion on what should you be aware of even when you don't ask for the accreditation body symbol, you should always, always review the scope of accreditation for the calibration supplier. Now, if you're not used to doing this, this may be a little tricky, but you can ask an Agilent representative for help, and we will try to show you how to do that if it's not obvious. But what you really want to do is you want to make sure that that schedule of accreditation is going to cover the parameters that relate to your instrument. And in the scenario, if a supplier offers calibration service, which is outside of their schedule of accreditation, then if I were in that situation, I would be asking that calibration lab, all right, for this instrument model XYZ, what is the expanded measurement uncertainty that I can expect for this instrument? Now, if you're not used to asking that question, you might wonder, well, how reasonable is that? And I can tell you from my company standpoint, that's a very reasonable question, and it's a very simple matter for us to go get a sample calibration report and pull that up and share that with you and say, well, here's a same model for a different customer. We'll black out their name, et cetera, and just show you here's what it is for this one right here. So it's a very reasonable question. You should have every right to expect that your calibration supplier not only knows what the measurement uncertainty is, but can provide it quickly on a sample basis. And finally, your risk of having an instrument be returned from calibration where it said pass, but in fact it's out of specification, is really going to be lowest when you know what the expanded uncertainty is, and that is significantly smaller than the instrument specification. Now, as we've said in this section here, one sure or very highly likely way to know that the measurement uncertainty is going to be low is if your calibration supplier includes the measurements that you're relying on in their schedule of accreditation, and you can go look at it and see what it is. All right, so that concludes the first portion of our module, and I'm going to hand it back to Trevor to cover the specific requirements when you include the accreditation body symbol on a calibration certificate.
Okay, thank you, Bob. The first point to make about putting the accreditation body's mark on a calibration certificate is that the work must comply with 17025. And this slide doesn't make that clear. But the point here is that throughout the world, laboratories that use the accreditation mark on the certificates shall comply with the standard ISO 17025. The other documents that are mentioned are, I would say, interpretations of it. From a manufacturer or a laboratory's point of view, they might see it as additional requirements. We could argue about that. P14 from ILAC has a policy about the use of the symbol. If you think about the fact that you could have some accredited work and some non-accredited work, most accreditation bodies allow both to be reported on the same certificate, provided the majority is accredited, and providing that there is no misleading intent or effect. And so it's a matter of whether, when you view that certificate, overall it is an accredited job. So the rules for that are in the ILAC document P14. You should be able to rely on the fact that the laboratory complies with it if they're accredited. Likewise, with the uncertainties of measurement, there are various schools of thought about how to calculate uncertainty of measurement. I think over the years it's getting more unified, and people are using the GUM, the Guide to Uncertainty of Measurement from ISO, properly called Guide 89, but that itself can be further interpreted, and there are some very useful documents available. I would recommend the UCAS one, but in fact it is of worldwide repute, and we have people downloading from our website a couple of thousand a month of the document M3003, and you'll find that on the UCAS website. It's a down-to-earth interpretation of the GUM with lots of examples. There's also an EA document which is similarly useful to interpret it. So accreditation bodies facilitate the implementation of this rather heavy GUM document by having their own guidance document. You'll get
Trevor,
that.
could I add a comment here?
Of course.
I simply wanted to second what Trevor just said. I was surprised that I don't have the link to the UCAS document that he mentioned, because the UCAS one not only makes it easy to understand, but it's one of the few references that has examples. So it's my personal favorite, and whenever somebody asks me for more information, that's the one that I go look for. Back to you, Trevor.
I'm pleased to hear that. Also, of course, an accreditation body will ensure that all the measurements that are presented as accredited are indeed within the scope, and that's something that we assess with some vigor. We jealously guard the use of the accreditation symbol. The way this is presented here suggests that Europe, Japan, and the Far East additionally apply the document G8. This may appear to be like that, but in fact G8 applies throughout the world, and the reporting of the pass-fail criteria, as treated by Bob very clearly just earlier, makes you stop and think that there's a big difference between people claiming that the product has passed or failed when they have a big uncertainty, compared with those claiming it passes or fails with a small uncertainty. And the document G8 tackles what to do about pass-fail criteria. It's a bit of a controversial subject, and at the moment there is some revision work being done on it. If we go to the next slide, there's G8. Just a second. The title speaks for itself. It's Guidelines on the Reporting of Compliance with a Specification, which is what many of you want. I believe that many users of equipment, sophisticated or mundane, really just want to know whether it meets the spec or not, because their use of it has been determined by choosing a specification and getting a piece of equipment that complies with it. And so on the next slide, looking at paragraph 2.3 of the ILAC document G8, we have the 4 cases being mentioned here. If we look at case 2, which is effectively the same one that Bob was using earlier, we have, going back a little, we have case 1, the item passes. Case 2, I like to describe as compliance is more likely than not. But people don't really want to see that written on a certificate. They just want a simple pass-fail statement. So with some confidence, you can say it passes, but you're not absolutely sure. And in the case 3, it's more likely to fail than not, but you could have it pass. There's a little bit at the bottom that's within the pass area, and the top one's a clear fail. So it's important to come to terms with the reality of this situation. And the reality is that you have those 4 cases. There are not just 2 cases, pass and fail. And if you shrink that uncertainty band to small amounts, you'll see that it becomes a lot clearer for a lot more measurements. And on the next slide, we have the, we have same thing shown, just a second. Ah, yes. So we can say that compliance is more likely than not in my terminology, and that shows the importance of choosing a laboratory offering a small uncertainty and a well-characterized uncertainty of measurement. Of course, there is a situation, and it's quite common, where the uncertainty of measurement is dominated by the performance of the instrument itself. Now, in that case, it doesn't matter if you go to a better laboratory with a lower uncertainty, it's not going to significantly affect the situation. So you wouldn't therefore have the lowest uncertainty work done on a relatively mundane instrument. And people do make that mistake. I think it's important for users to understand that if they have a rudimentary instrument, they're only going to get rudimentary performance out of it, however the uncertainty is low of the laboratory that they've chosen. Nevertheless, where a piece of equipment claimed uncertainty or claimed accuracy capability is not much different from that claimed by the laboratory, then you should be rather worried about that, because the chances are there that you'll end up with compliance more likely than not, or fail more likely than not. One of the things that's in G8 that's very important is that accredited laboratories must inform their customer of the pass-fail conditions. And on the next slide,
sorry, Trevor,
I understand that Agilent. Sorry, Bob.
Sorry, I was just not synced up with you. Keep going.
Okay. On this slide, we show that Agilent is moving towards complying with the ILAC G8. Now, in the United States, there is some difficulty with G8, and the modifications being made to it at the moment will handle that to some extent. But I would applaud a situation in which a very clear pass-fail statement with mention of the uncertainties and how they're taken into account, that should appear on the certificates, in my view. And I understand that the Agilent Cal Plus Uncertainties service is going to do that. Other laboratories in Europe do this, increasingly so, and I'd like to think it will increasingly spread across the United States. On the next slide, we mention the document P14. Same subject. This is about the way the uncertainties are calculated and presented by ILAC members. It's effectively covered by the GUM at 3003, and the way it's reported is covered by G8. This is rather complicated. There's a lot of documents, and if you choose an accredited lab, you can be sure that an accreditation body like mine has looked into this, and you needn't worry. I'd like to mention that all the ILAC documents are in the public domain. They're easily downloaded from the ILAC website, or if you simply type a word like uncertainty or measurement plus the name of the document into Google, you'll get it in no time. It's usually the first hit. If you write ILAC G8 into a search engine, you'll get it. Okay, and on the next slide, this is a discussion on the bit that's contentious within document P14. It's a restatement of what's in 17025, that we insist that accredited laboratories shall report the uncertainty of measurement and that the uncertainty is computed according to the GUM. And it's worth noting that whilst this is under revision, you should keep an eye on the changes announced by accreditation bodies, particularly those in the US, as we try and get this more equally treated across the world. Now, Bob will discuss an example of a calibration certificate with you now.
Thanks, Trevor. So when you receive a calibration report, for example, this sample report from one of our calibration services, which would be the Agilent calibration with uncertainties and also with guard banding according to ILAC G8, then in that case, this is coming from a U.S. laboratory, this particular example. So it has the A-class one. If it were coming from, say, the UK, then it would have the UCAS one, of course. And in this case, we're telling people that it is according to 17025, and also the way that Agilent does 17025 when we use the ILAC G8 criteria that turns out to meet one of the compliance methods for Z540.3, which is of interest to many people in the United States. Perhaps more important in this report, as always, the most important part is the data. And as Trevor was just telling you, that when you see an accreditation body symbol on there, you should have every reason to expect to see the measurement uncertainty, again, per the Guide 98, the ISO GUM. And so I've just circled it in red on this particular slide, and you can also see it up above in the chart as well. So that's, you may or may not see a chart, but you should certainly expect to see the tabular measurement uncertainty when you are receiving a report which includes an accreditation body symbol. So that brings us pretty much to a summary for this portion. In fact, summary for the entire webcast. So just before we go into questions here, I would like to do a little bit of a summary, which is we emphasized, I think, both Trevor and myself, the importance of the schedule of accreditation, and at the same time to make sure that everything that you need to have done is in fact included in that accreditation. I do want to make one point, which is that at Agilent we try very, very hard. There are corner cases where this doesn't happen, but essentially all the work that we do will be within our schedule of accreditation. Again, if you're smart enough to know one of those few measurements where we haven't been able to do that, then you don't need this webcast. But for everybody else, we try very, very hard to do that, and the reason is that's what if we were sending our instruments to somebody else, that is what we, Agilent, would expect, and we try very hard to be the premier measurement company. And as I remind everybody internally, if you want to be the premier measurement company, that's what you need to do. One other point, which I didn't mention earlier, but I do want to mention in passing, and that is regardless of which calibration service that you select. So we're very happy when you ask to see the UCAS symbol on one of our calibration reports. We're happy to do that. We provide those deliverables. We do have some lesser expensive alternatives where you don't get all of the guard banding, et cetera, but I do want to let you know that in those cases we use, for the measurements themselves, we use the same people, the same automated test procedures. We're using the same test equipment, which provided the known and as low as we can measurement uncertainty. So we don't change our procedures, we don't change the test methods, simply are not providing as many deliverables on some of our calibration services. So before we jump to questions, I just want to mention, here we are today, 15th of January. This has been Demystifying Calibration Accreditation. If any of you have been exposed or have interest in the current Z540-1, that's an American National Standard, that one has been replaced by Z540.3, and we do have another seminar on the 13th of February. So you'd be welcome to join us for that. And these slides will be available. The registration for that would be at this link. So I think that's it for those, and we are now ready for questions. Luca, do we have any questions?
So thanks, Bob and Trevor. First of all, let me just stop a moment and thank you for this very, very crisp presentation. And just a reminder to everyone who would like to ask a question, you can use the Q&A little panel on the bottom right-hand side of the screen. I've also posted, as we were going through the presentation, a comment more than a question that we got from one of our participants. And again, anyone who would like to ask questions, he or she can use the Q&A box at the bottom right. I also remind you that as soon as we will be closing the session, there will be a very, very short feedback form that I'd like to ask you to to spend a minute to fill. We have a couple of questions that also came through during the presentation that I think we've kind of answered it to some degree. Bob, the first one is, if two calibration laboratories are both accredited, does that mean that they have the same quality?
Sorry, I put myself back on mute. Yeah, well, we did try to address that. The front page may look nearly identical between two different calibration laboratories, but it's really only by going back and looking at the actual specifics in the schedule of accreditation. That's where you really find out what can these laboratories do, what has an assessor taken a look, made sure that the people have the proper skill, looked at the test laboratory standards that they have, and therefore made a determination of what is the best measurement capability and the corresponding measurement uncertainty that they can provide.
Right, right. There's also another comment that I got about different accrediting bodies. I believe that you've kind of touched on that on the mutual recognition. So is there any difference, for example, for an Italian customer requesting an accreditation from SIT or what is today called Accredia versus getting one from UCAS?
Well, since we have Trevor here, why don't we let Trevor answer that one?
The answer to that is that the essential requirements should be the same, and the work from an Accredia accredited laboratory should be comparable with the work from a UCAS accredited one for the same range of measurements and the same uncertainties. Going back to the previous question about would they be the same quality, the work done at two different laboratories, if they're accredited with the same range of measurements and the same uncertainties, the technical answers should be within the same population of uncertainty. So the answer is yes, it's the same technically, but if by quality you mean attention to the customer's time frames, to the level of service offered for peripheral activities, maybe the quality of the documentation perhaps, not in terms of the words in it, but the way it's provided, and the kind of customer service issues, not all labs are the same by any means. And so a laboratory should be chosen for its scope and for the good service it gives to its clients. And that occurs throughout the world. And if you go to the Italian branch of one of the big laboratory groups that's accredited by UCAS in the UK and by Accredia in Italy, the answers of the measurement should be the same, but you may not get the same service. Some countries have a slower culture than others. Some have a faster one. I think the US hits it for the speed, doesn't it? Thank you, Bob.
Cheers.
Thank you very much, Trevor. I think it's an excellent add in terms of all the peripheral services that laboratories can give in the communication to customers and the turnaround time, and in everything that basically pretty much makes up a service experience. Okay, I think we are approaching the top of the hour, and I see another couple of questions, but they're kind of more or less on the same theme about scope of accreditation. So let me just call the last one out here, Bob. How can I tell if a lab is accredited for the parameters that correspond to the specs that my company relies on? And I think we've touched on checking on the scope of accreditation during the presentation already. Is that correct?
Yes, I believe so.
Okay, so that's pretty much, it's been answered as we have progressed during the presentation. So at this point, if there's no further questions, I would like to, again, thank the speakers, the presenters, Trevor in particular, for attending from UCAS, but as well all of the attendees today and all of our customers and people who are interested in the subject. So once again, do spend a moment to fill up the survey at the end of the presentation, and I hope that we have a chance to be together again on another seminar soon. Thank you very much, and this